Krishna, working as an assistant professor in Civil Engineering Department, Anurag Engineering College. I would like to explain about the Unit 5, that is design of rigid pavement. Already we are discussed in the previous units, that is design of flexible pavement and stresses in flexible pavement and stresses in rigid pavement and introduction to pavement design, and after that you have to come to that fifth unit, that is design of rigid pavement. In this previous experience we have to know all the important points in the design of that flexible pavement. After that, what type of factors should be influenced in the design of rigid pavement should be understanding from this unit. That is, first of all, what is the mean by rigid pavement? Rigid pavement, it is nothing but it's consist of 2 to 3 layers. It should be surface coats primarily constructed with cement concrete pavement slab portion, and this is the checking for test of flexural stress we have to find out. In that rigid pavements, compared to flexible pavement, the number of layers provided in these rigid pavements are very less. In that situation, we have to provide on that particular pavement using the joints on that particular rigid pavement. Here in the chapter, what type of joints should be included in this particular chapter, and what type of design used for the design of rigid pavement, and reinforcement provided or not, and without reinforcement provided, as you know, this all are considered in this chapter. First of all, what is the importance of joints in rigid pavements? In particular, rigid pavement should be constructed with cement concrete pavement materials. So in that situation, first of all, improving that characteristic strength of that road for that cement material, we have to introduce the reinforcement, nothing but joints. Why? Because here we have to provide long distances, and with the cross-sectional geometrical point of view, it should be very large dimensions we have to prefer in that particular pavement. In the situation, we are newly introducing the joints should be provided on that particular these types of pavements. These joints are concrete pavements. It is a optimal regular interval you have to maintain on that longitudinal side, and to this should be allow the shrinkage and contraction, expansion and curl up or down directions. It should be involved. After that, the slab shrinks due to sudden loss of moisture from concrete before it's hardened completely, and the degree to which the installing joints brings relief from the critical stresses of the slabs, and by load transferring, it is called efficiency of joints should be decided, and the joints should be spaced optimally to maintain the structural efficiency, to relieve warping stresses and prevent the occurrence of cracks during the temperature displacement of the slabs. Some of the types of the joint should be commonly provided on that particular rigid pavement, that is transverse joint, and the second one is longitudinal joint. In this transverse joints should be categorized into again two types, that is contraction joints and expansion joints. See here, one is the longitudinal section of that particular road surface. In here, the surface course, it should be number of joints should be provided on that particular road structure. It should be longitudinal direction and lateral direction. We have to provide some of the black lines. That black line should be indicated with joints, and it should be slab thickness. It will be represented in this longitudinal direction. It should be provided. It is called double bars. In the transverse direction, it should be provided as the tie bars. These double bars and the tie bars are very influenced to use the bearing of that load on that particular pavement due to acting on that vehicles. And after that, contraction joints. Coming to contraction joints, contraction means it should be allow the contraction occurring on that particular road. Here, the contraction joints along the transverse direction to take care of the contraction of the concrete slab due to its natural shrinkage. Contraction joints are planes usually vertical separating the concrete in a structure, or a pavement placed at a designed location. Contraction joints is placed such a way that interfaces least with the performance of the structure as well as prevents the formation of objectionable shrinkage cracks elsewhere in the concrete. Where the crack should be implemented or crack should be involved in that particular direction, that type of direction I have to provide the contraction joints. And coming to this is the contraction joints, that to the continuous load you have to provide the some gap that is called groove. From that groove it should be object point to form a one contraction crack. That contract it will be enhanced with contraction joints. Coming to expansion joints, this is also called as moving joints. Why it is called expansion? It should be allow the expansion on that particular pavement. It should be occurring on the transverse direction, and it should be the joint should be movable from one place to another place. So that's why only it is called as the moving joint. An expansion joint, it is a mid-structure separation designed to relieve stress on the building materials. It is caused by building movement introduced by thermal expansion and contraction caused by temperature changes. It should be mainly applicable to effect of that temperature stresses. This is the expansion joints, the acting on the temperature stresses very severely on that particular pavement. The type of crack should be very expanded, and that should crack, it is called as expansion joint. And for these joints it should be minimized to load bearing on that particular pavement. Some of the reinforcement should be used. That reinforcement it is technically treated as one is the double bar and one is the tie bar. One is the double bar means it should be based upon the reinforcement placed on the direction of that particular road. The double bars are placed in the transverse direction. It is called double bars. It should be concrete and the part taken partial wheel transferred from one slab to its another slab. Next, the double bars are also axial thermal expansion and contraction of the concrete slab along with that axis of the dowel. Next, transfer the part load across the adjacent slab and stresses becoming the critical, and when it will provide means the double bar should be positioned at mid depth of that slab, not only edges and not only near the support. It should be provided on the mid of the thickness of the slab and concerned equally about indented lines of that joint. They should be aligned parallel to that finished surface of the slab and center line of the carriageway to each other. So see here figure 1 and figure 2, the difference between the figure 1 and figure 2, we are not from the figure 1 we are not providing the double bar on that such particular case. The base of that material, soil material should be loosened condition. In the situation the some portion of that slab it should be downfall will be seeing in this figure number 1. For the preventing of this failure you have to provide the double bar. You see here figure number 2, after providing the double bar, the two roads connected with the one single bar, it should be used to prevent the expansion and contraction of that particular road joint. And coming to tie bars, in the transverse direction you have to provide in the double bars, in the longitudinal direction you have to provide the tie bars. This is very perpendicular to provide on the double bars. It should be very capable to provide bearing the tensile stresses. These bars projecting across the longitudinal joint shall be protected from the corrosion for 75 mm on each side of the joint by protective coating of the bituminous paint. For resting of that reinforcement you have to prevent from that failure, you have to coat it on that particular painting. It should be occurred in this bars. These tie bars provided at the longitudinal joints, it should be provided by mechanically or manually. It should be inserted in the plastic concrete from the above by vibration using a method which ensures correct performance, placement of the bars and recompaction of the concrete around the tie bars. See, from that figure 1 and figure 2, from that transverse joint, longitudinal joints, you have to provide the tie bars on that particular slab thickness, and here complete perpendicular to that the tie bars, it should be lateral direction. You have to provide on that particular road situation, that is called double bars. This is the main difference between the tie bars and double bars. Next, coming to the design of that rigid pavement, here some of the factors highly influence on that particular design of that rigid pavement. What type of factors should be highly influenced on that particular design? The two major factors primarily to be considered for the design of the rigid pavements, that are, one is the heavy traffic load, and second one is the temperature variation between the top and bottom of the CC concrete slab. Here, the some of the other factors also included on that particular design, but these two parameters are very highly influenced to design of that particular pavement. The other factors, such as that is the temperature stresses due to expansion or contraction of the rigid pavement during summer and winter season. Here we are considered mainly seasonal variation and daily variation. Why? Because the temperature should be variant primarily on that seasonally, and daily temperature means that is considered as the midday and midnight temperatures you have to consider here. After that, volumetric changes in that subgrade due to shrinkage in that moisture and temperature, loss of subgrade support due to some reasons of that some locations. And after that, some of the Indian Road Congress that should be about the rigid pavement should be categorized by IRC 58 2018. This IRC 58 Indian Road Congress should be implemented some of the standards. We have to follow the standards and maintain the design criteria to provide the particular design of the rigid pavement. That is, some of the following steps should be followed for the design. That is, first of all, step 1. First of all, you have to find out the design values for the various parameters. For that, calculating the design values, you have to give in some inputs on that particular step 1. After that, select a trial design thickness. First of all, you have to assume how much thickness you should be provided on that particular location for bearing on that particular wheel load configuration. That trial thickness you have to provide after checking should be implemented on that particular trial depth. After that, compute the repetition of axial loads on the different magnitude and different categories during the design life. That total through design life on that particular situation, you have to find out that how many number of repetitions should be acting on that particular pavement on that particular life. That should be number of axles should be considered here. In that step 4, find the proportions of axial load repetitions during the day and night periods. Why? Because in the daytime, number of vehicles should be passing very high compared to night time. The ratio or number of vehicles should be passing on that pavement should be very low. And after that, in that step 5, the estimate the axial load repetitions in the specified 6 hours, not only 2 hours, not only 4 hours. You have to must and should take 6 hours duration for taking the survey on that number of vehicles passing on that pavement. The maximum temperature differential is assumed to be remain constant during the 6 hours analysis of the bottom up cracking. And after that, estimate the axial load repetitions in the specific 6 hours period during the night time. The maximum negative temperature differential during that night is taken half a day in the maximum temperature. It should be temperature should be negative differential means 50 degrees should be developed on that particular location. After that, only those vehicles whose front and first rear axle come between and transparent joints are considered here. And after that, after knowing the load repetitions, we have to find out the flexural stresses acting on the pavement. Based on that flexural strength, the concrete thickness should be provided on the pavement. It should be capable or not of that single and tandem axle load should be acting on the pavement. In this should be the single and tandem axle load. Some of these two single and tandem axle loads should be maintained as the ratio less than 1 for the slab should be safe, and it should be getting more than 1, the slab should be very dangerous situation. At that situation, you have to replace or modify that assumed trial thickness. After that, you have to compute the flexural stresses at that center of the transfer joint. The rear axle close to that following joint, it should be same panel under negative temperature differentiates, and it should be determine the stress ratios and evaluate that single and tandem axle loads. Some of that two tandem axle loads it should be maintained less than 1 for the slab, and it should be maintained as the against bottom up cracking. And after that it should be maintained particular location after stress values, and after finding that more number of values and flexure strength values. Based upon that, how much thickness you should be provided on that particular pavement on that particular location, based upon the load reputations and design life, it should be manually calculated, and by using following the some of the guidelines of that IRC 58 2018. Based upon that following assumptions only, we have to design that particular total rigid pavement. These are the criteria mainly involved in this particular unit. Okay, thank you students.